We are currently at the end of the grant review process and wanted to ask you just a couple of questions about your project titled
Definitely.
Validation and Implementation of a Novel Tool for Predicting Pathogenicity of Variants of Uncertain Significance in Familial Hemophagocytic Lymphohistiocytosis Genes.
You got it there.
Woo!
It's a mouthful.
Yeah,
Yeah.
I need a break now.
Yeah.
First of all, can you just explain to us kind of in layperson's terms what the project is and what its significance is?
So the project aims to help us better understand the functional impacts of, changes in the HLH genes, right? So when patients who are being considered as having HLH undergo genetic testing, there are three different kinds of results you can get when you have genetic testing. You can either have a positive result, which means that you have a change in one of the HLH genes that has already been described, let's say, in others with HLH. So you know that that change is a change associated with disease. You can have a negative result, right, where you don't find any changes in the genes. And in that situation, you can be pretty confident that the patient doesn't have a familial or genetic form of HLH. And then the third category of findings is something called a variant of uncertain significance. And in those situations, you can find a change in a gene, but there isn't yet enough information to really know whether that change is associated with disease or not. And in those situations, it leads to a lot of uncertainty. And, why is that important? Well, we know that patients with the familial forms of HLH, right, they're prone to disease recurrences and can only be cured with hematopoietic stem cell transplantation. Whereas patients who may have a non-familial or secondary form of HLH, usually if you suppress the immune system enough to get them over that bout of hyperinflammation, they may never have a recurrence, and certainly they're not likely to need hematopoietic stem cell transplantation, which is where you normally replace a, problematic or challenged bone marrow with a healthy bone marrow from another person. So trying to decipher whether a genetic change is truly impacting the function of the encoded protein is very important. So this grant aims to do that, to try to express normal or altered forms of HLH proteins in cells that lack that protein and see whether the kind of function of the cells can be restored or not. So I'm not being very clear with my explanation, but it's really aimed at testing, how do changes in genes impact the functions of the encoded proteins? And the proteins really are the workhorses of the cell, which carry out the cell's functions. And ultimately, this is aiming to help people better understand whether a patient has primary or secondary HLH, which of course will have clinical implications. Does that make sense? Hopefully.
Yeah, yeah, that makes sense. It sounds like it would have a great impact on the community and the patients and the families, just because like it's hitting a crossroads, right? Like going one way or the other based on whatever it is that you find out.
Yeah, and I'll tell you, the vast majority of changes in the HLH genes that have been reported to date are these variants of uncertain significance. So if there are, public repositories of genetic changes that clinical labs have identified, and the vast majority of changes for these genes are variants of uncertain significance, which means that there's a lot of patients out there for whom we don't really know, do they have the primary or the secondary form, the hereditary or non-hereditary form of the disease. And in those situations, usually what happens is you end up treating a patient with steroids or chemotherapy. And if their disease goes into remission, you end up stopping treatment and then you wait and watch, right? And if their disease recurs, you assume, well, that variant probably was a challenging or a damaging variant associated with disease, and you move to transplant. And if the disease doesn't recur, then you assume that that variant was not a problematic variant, maybe more of a normal variant from one person to the next. So the purpose of this is to try to avoid a situation like that where you have to wait and watch and see what happens and really have a better understanding of which direction to head clinically sooner in the trajectory of the disease.
I would imagine that would give it has implications to give the patient and the family more peace of mind as well, because if they're just waiting and watching, it could be anything that happens. They could be just like scared that your butt just fell out.
Oh,
Scared that
yeah,
this could be the disease reoccurring.
exactly. And it also provides important information for other family members. So if it is the truly hereditary or primary form of disease, right, it has implications for other family members, like siblings, for example. So it definitely can provide helpful information that may reassure parents one way or the other, and also provide important information for guiding, counseling, and testing of other family members.
So how would this funding help the project?
Well, in order to do the project, we need to generate, how do I say this, kind of artificial mini genes that are either normal or have the different described variants that we're studying into them. And then that needs to be introduced into cells, and you need to see whether or not those cells have functionality or not. So all of this requires, actually what we're doing involves introducing these genes into primary cells from mice, but it requires reagents, so we need to pay for the manpower to carry out the experiments and purchasing reagents and supplies. Without those, none of this would be possible. So it's a critical resource to just do the work and be able to better understand. And ultimately, Kathy, part of this project, which I did not discuss yet, is I've been working with a colleague, Lauren Meyer, you know her well, who has worked with computational biologists to come up with a computer program, like an algorithm that will help to predict whether variants that span these genes are more likely or less likely to be damaging, i.e., more likely or less likely to be associated with the familial forms of HLH. And the reason that we're doing these functional tests is that we're trying to validate the predictions that come out of her algorithm. And if we can do that, we don't need to do that with thousands of variants. We can do this type of validation with 20 or 30 or 50 variants. And if we find that the results of our experiments match the predictions that come out of her algorithm, um, basically that means you can trust the algorithm, or you can hopefully trust it. And so we can use this algorithm to predict the pathogenicity of essentially any change in one of the different HLH genes. And our hope is to create a portal where if a provider from a medical center anywhere in the world, had a patient that they were considering HLH and they found a change in one of the HLH genes, they could put it into the portal and see what the algorithm predicted. This genetic change is very likely to be damaging, i.e. associated with the familial form of the disease. This hopefully will, even if it's not one that we validated, as long as, our initial work confirms that the algorithm is working properly, ultimately, this information could be very useful for providers around the world to predict pathogenicity of a whole range, hundreds of different variants in the different genes. So to get back to your question, the funding provided by the grant will allow us to carry out, a limited series of experiments to try to functionally validate some of the variants and hopefully confirm the efficacy of her computational algorithm. So I think the impact will be much broader than what we're actually testing in the lab, but could be very important down the road.
That sounds like it could have far-reaching implications,
Yeah,
which is really cool.
yeah. And what's cool at St. Jude is that there's there's a team actually of computational biologists that are experts at making these portals, where information can be made available publicly. And I'm hoping to be able to partner with them once we've validated the algorithm to develop this portal. And, we can then advertise it through the HA or the HS as you wish, or through a lab site. And, it has to be recognized that this is not a clinical test, but, it's a predictive test that's aiming to help people make treatment decisions down the road if they don't have access necessarily to labs that could do the functional testing themselves.
Wow. Thank you for sharing all of that. It's fascinating. Being not a scientist, it's all fascinating to me just to hear what is possible, not living in
Hopefully
that
I'm
world.
explaining it in a
Yeah,
reasonable way. Sorry.
yeah, absolutely.
Yeah.
Well, you may have guessed that the reason we invited you on this call was to let you know that you were chosen for funding.
Oh. Well, that's not
And
what I thought, so I'm glad.
oh,
I thought you were going to ask me about my overlap.
oh,
About my potential for overlap. So I'm like, I don't really have potential for overlap, but uh,
no, we wanted to let you know that you have been
uh,
chosen by the committee
thank you.
to receive the grant funding, and
Yay.
we wanted to give you that little piece of news here right before the
Oh,
holidays.
oh, I'm very excited. Thank you, Kathy. Thank you, Deanna. That's great.
Yeah.
That's wonderful.
Congratulations.
Yay. Oh,
Yeah.
well, you guys trust me. We are working on this so hard now. So we're going to make this happen. I'm very excited about it. I've got a great student, Emily, and we've got Sabrine all over it. And I'm working with Lauren and, we're rocking and rolling. We've made all our mutants. Now we're at the point where we're ready to express them in the cells. And we had a little difficulty on the first go around, but don't worry, we'll get it figured out. So excited about it. Thank you.
We're really excited
Yeah.
too. It sounds like a very important project and really eager to hear how things are going as we continue to follow you in the project. So thank you for your passion for doing it, and we're super excited.
Thank you. Thank you so much. I really appreciate it, both of you guys. That's a wonderful news. Makes me feel very happy for the holiday season.